Welcome back to the Deep Dive, where we take your stack of sources, the articles, the internal white papers, the deep research, and give you the knowledge you need in a fraction of the time. Today, we are looking at what can only be described as a corporate speed run. We're talking about a major enterprise tech project, a really complex architectural build. By all industry standards, this thing should have taken 6 months. Instead, it was done in just 8 weeks. So the question isn't if they did it, but how. And the answer seems to be by using AI not just as, a coding assistant, but as the chief accelerator of the architectural design itself. We're diving deep into this pretty remarkable case study from a company called 6 Trends Inc. They took on this huge task of building an intelligent call center support system for a major client. And we're talking a ground-up build compressed into this just unheard-of 8-week deadline. And the person right at the center of it all, the one calling the shots, was the CTO at 6 Trends Inc., Tom Barker. He's the one who headed up the team that pulled this off.
And that tension, right? The 6-month expectation versus the 8-week reality, that's really what drives our whole deep dive today. Our mission is to unpack the specific architecture, the strategic constraints they put on themselves, and crucially, the delivery strategy that let them hit that date. It really forces us to rethink what AI's role is in enterprise delivery, which means we have to ask the big question right from the start, just how much of a typically human, highly specialized and detail-oriented process like defining an enterprise architecture, picking components, writing the code to provision it all. How much of that was just handed over to an intelligence system to get that kind of speed?
That's the real shift here, isn't it? The AI wasn't just like writing the final application code. It was creating the foundation, the actual engineering blueprints.
Yeah, exactly. And to really feel the weight of that timeline, you have to appreciate the project scope. I mean, if this was just some simple single-purpose app, 8 weeks would be tough, but, maybe doable. But this was a multifaceted system. It had to manage complexity across different users, and it needed, seamless integration.
Okay, let's break that scope down, because a 3-part system means you have 3 things that need to work together perfectly. So what were the core pieces 6 Trends Inc. had to build in those 8 weeks?
Right. So the system was designed to give support across 3 really critical touch points, and all of them relied on connecting a bunch of specialized Google Cloud services. So the first component was automated ticketing. When a user calls in, the system has to listen to their, natural speech. It uses speech recognition, feeds a transcript into a large language model, an LLM, and the LLM's job was very specific. Analyze the conversation, figure out the user's intent, and then automatically fill out a structured form for a new support ticket.
Okay, that right there saves the call center agents a massive amount of time. Instead of listening, pausing the call, typing out a summary, the AI is just doing that heavy lifting in real time.
Precisely. It turns that messy, unstructured conversation into clean, structured data, but that just gets the ticket in the system. The real help, the diagnostic help, is the second piece.
And that's the staff diagnosis support. I imagine this is where the pressure is really on.
It is. So while the human agent is talking to the user, the system has to act like an instantaneous co-pilot. It needs to pull in information from all these varied sources. We're talking old case studies, dense tech manuals, a huge Q&A database, and then bring up relevant, summarized info right on the agent's screen.
Wow.
It helps the staff diagnose the problem faster and give better advice without putting the customer on hold while they go digging through old systems.
That's incredibly complex. That's information retrieval under extreme pressure. The LLM has to understand not just keywords, but the actual context of the conversation. It's a huge undertaking.
And then you have the third function, which is all about continuity, out-of-hours guidance. This is basically a simplified version of the first 2 things, the automated ticketing and the diagnosis support. It's for users who call when no human staff are around.
So it manages their expectations a bit.
Exactly. It can give some initial troubleshooting steps, offer to create a ticket automatically, but, and this is crucial, the system had a built-in guardrail. It would clearly state that the guidance was just preliminary and needed to be checked by a human during working hours. That shows real architectural maturity, They understood the system's limits.
So that Scope 3 integrated systems handling data intake, real-time co-piloting, and automation, that makes that 8-week deadline feel not just ambitious, but, impossible.
It really underscores why they needed this new methodology. I mean, we have to keep coming back to that time constraint. The client demanded the first release in 8 weeks. And we know a project like this would normally take 6 months, minimum.
So how do you shave off 4 months of work?
That constraint, that hard deadline, it forced their very first strategic choice. And this is the foundational trade-off. They couldn't afford to waste time exploring options. They settled immediately on Google Cloud, right at the start.
Wait, hold on. Isn't picking the platform usually a huge time-consuming part of these projects? The whole AWS versus Azure versus Google Cloud bake-off?
Absolutely. In a traditional project, you could spend 4, maybe 6 weeks just on vendor evaluation. You're drafting RFPs, doing benchmarks, security reviews, comparing costs. By locking into Google Cloud on day one, Tom Barker and his team just cut all of that out. It might feel restrictive, but it instantly saved them weeks of deliberation.
So the biggest gamble was choosing speed over a thorough options analysis. Was that the riskiest move they made?
Strategically, yes. They bet everything on Google Cloud having all the right pieces. The speech recognition, the LLM capabilities through Vertex AI, the serverless infrastructure. If they'd hit a wall 2 weeks in, found a critical feature that GCP just couldn't support, the whole project would have been dead in the water. But that choice, that platform lock-in, that's what paved the way for the real acceleration that followed.
Okay, let's unpack this, because
Yeah.
here's where it gets really interesting. The methodology. We hear a lot about AI writing little bits of code. But how did Six Trends Inc. use Gemini to actually build the architecture and not just the final application? How did it become the lead engineer?
This is the core innovation. Gemini was used through really focused prompt engineering to basically replace or drastically speed up huge chunks of traditional development work. And it wasn't about the AI being 100% perfect all the time. It was about the AI giving them a, say, 80% complete draft in minutes that would take a human engineer days or weeks to create.
Okay.
They had Gemini playing 4 distinct roles to generate all the docs and code they needed.
So start at the highest level. What was role number 1?
Role 1, architecture definition. This is the narrative part, the what and the why. Gemini was prompted with all the client requirements, the 3 support systems, the deadline, the Google Cloud constraint, and it was tasked with summarizing the solution flow and defining the whole architectural approach. It drafted the high-level plan in hours, not weeks.
Okay, so that's the plan. What's next?
Rule number 2 follows right from that, schematic generation. Once the definition was set, Gemini was used to turn that abstract concept into a visual, codifiable engineering blueprint. It was prompted to lay out the solution architecture as a UML defined using a tool called Plant UML.
For listeners who don't know, what is Plant UML and why is using AI to generate it such a big deal here?
So Plant UML is a scripting language that lets you describe a diagram using just text. You write out the components and how they connect, and the software generates the actual UML diagram. Normally, an architect would spend days in a graphical tool, manually dragging and dropping boxes and drawing arrows. By using Gemini to generate the Plant UML script, they just bypassed all of that manual diagramming. The sources do mention, of course, that human refinements and corrections were needed along the way.
That's the part I'm curious about. What do refinements and corrections actually mean? Was the AI just making stuff up?
It means the human architects shifted their job from creation to verification. The AI's first draft might suggest an inefficient connection, or maybe it missed a security boundary. The human's job wasn't to fix typos. It was to check the conceptual integrity of the whole system.
So correcting a few arrows is way faster than drawing the whole thing from scratch.
Infinitely faster. The initial generation was incredibly quick and, more importantly, structured enough to be useful.
Okay, so it's generating the blueprint that defines all the components. I assume that blueprint then leads directly to provisioning the actual cloud infrastructure. That's another huge time sink.
And that brings us to the bridge between design and deployment. Rule number 3, infrastructure as code, or IAC. Gemini was tasked with generating the Terraform code needed to provision all the core resources in Google Cloud, based directly on the Plant UML schematics it had just made.
Wow.
Think about that. The AI defined the problem, drew the solution, and then wrote the instructions for the cloud to build it. That step alone can replace weeks of a human engineer writing complex configuration files.
And then after the foundation is laid, the final piece is the actual application code.
Exactly. Rule number 4, application logic. After the infrastructure was defined with IAC, Gemini then generated and amended the actual application code, the code that would run inside the Google Cloud function. It was this whole integrated pipeline, vision to schematic to infrastructure to application.
That is what really allowed for that time compression. Let's list the specific Google Cloud services provisioned with that IAC, just so we're clear on the backbone of the system.
Absolutely. The Terraform code spun up several key services. For data storage and the Q&A database, they used Firestore. For the asynchronous communication between all the parts, they used PubSub, which is Google's messaging service. The main application logic ran on cloud functions, so it was all serverless. And critically, for all the AI magic, the speech recognition and the LLM analysis, it enabled the necessary Vertex AI APIs.
So speed was everything, and they got it by leaning hard on AI.
Yeah.
But let's talk about the trade-off here. Relying this heavily on AI for the foundational architecture, that introduces a lot of risk, doesn't it? If the AI gets that foundation wrong, the whole thing comes tumbling down.
It absolutely does. And the sources highlight this as the single biggest threat to that 8-week timeline. A subtle mistake made by the AI in the first hour could sink the entire project weeks later. The reliability of the final product, given how much AI contributed, that had to be addressed head-on.
So how did Tom Barker's team at Six Trends manage that risk without just slowing the whole process back down? I mean, if you have to manually check every single line of code, you lose all the time you saved.
They built the quality assurance process specifically for this. They implemented a QA workflow with humans in the middle. The human experts weren't writing the code from scratch. They were acting as very focused validators and refiners of what the AI produced. Their job wasn't just to check syntax, it was to ensure conceptual integrity. They were asking questions like, did the Terraform code introduce unnecessary costs? Does this architecture have security flaws? Is the messaging queue configured to prevent data loss? They were doing high-level risk assessment on AI blueprints.
That makes a lot of sense. The human team becomes less about creation and more about validation and security. You optimize for speed while keeping a high bar for verification.
Precisely. This hybrid model-fast AI generation, followed by focused human validation, is the critical thinking step. It shows that speed requires safeguards and that these systems are best used when they accelerate the creation process, letting humans focus on quality and risk.
So let's bring this deep dive home. The outcome of this ridiculously ambitious 8-week project. They met the client dates, not just on time, but with 2 days to spare. Delivering a 6-month project in under 8 weeks is just staggering.
And if you connect this to the bigger picture, this case study really shows a powerful new pattern for enterprise delivery. The success wasn't just about smart coders working late nights. It was the direct result of 2 strategic decisions working together. First, that focused strategy, committing to a single cloud platform from day one to eliminate all that evaluation time. And second, the radical use of AI Gemini in this case to handle those initial architectural steps. The combination just achieved this massive time compression.
And credit where it's due, this accelerated project, achieving a 6-month timeline in 8 weeks, was successfully led by Tom Barker, the CTO at Six Trends Inc. It really proves that this kind of technological innovation has to be paired with equally radical leadership.
Which leaves us with a final important question for you, the listener, to think about. Based on this case study, where AI handled the heavy lifting of architecture definition, schematic generation, and initial code generation, what happens now to the standard 6-month project timeline? Is this kind of acceleration, driven by intelligent systems, simply becoming the new baseline for how fast enterprise technology can be delivered? Something to think about for your next big release.